Hello everyone and welcome. My name is Angie Juliana Escobar and my partner Juan Ángel Arbelaez. In this presentation, I'll be talking about a fascinating research article titled Statistical Process Control and PDCA for Quality Improvement in the Mexican Automotive Industry. This paper was written by a group of researchers from University Iberoamericana in Mexico City and the National Council of Humanities, Science, and Technology. The study focused on how to well know quality management to statistical process control, also known as SPC and PDCA cycle, can be combined to improve manufacturing quality in the Mexican automotive industry.
Let's start by explaining what statistical process control or SPC actually is. SPC is a statistical method used to monitor and control a process. It was first developed by Walter Stewart in 1924, and it has become a concern in quality management. Basically, SPC helps companies detect and reduce variability in their production process. This variability can be caused by two types of factors. Factors number one, common cause, which are natural variation that always exist in a process. And factor number two, and actionable causes, which are specific problems that can and should be corrected. The goal of SPC is to distinguish between these two causes so that we can write correctly, not overreaction to normal variation and not ignoring real issues. When applied properly, SPC improves quality, increases productivity, and reduces cost. It also motivates employees because they can see data-based evidence of their performance and process improvements. SPC use control charts, for example, the X bar and R chart, to visualize process behavior over time. These charts show whether a process is stable and capable of meeting quality standards. Now, let's move to the PDCA cycle, which stands for Plan, Do, Check, and Act. This method was originally created by Walter Stewart and later popularized by W. Edward Deming. It's one of the most widely used approaches for continuous improvement in organization. Here's how this works. Plan. Identify a problem, analyze it, and plan a possible solution. Do. Implement the plan on a small scale. Check. Measure the results and compare them with expected outcomes. And act. If the plan worked, standardize. If not, analyze what went wrong and start the cycle again. PDCA is a never-ending loop of learning in a problem. In this research, PDCA was combined with SPC to achieve both data-based control and structural improvement in a manufacturing process.
To understand the context, let's take a look at the Mexican automotive industry. The story began in 1925 when Ford opened its first production line in Mexico. However, it wasn't until in 1962 that the Mexican government established public policies to develop a strong manufacturing environment. From that point on, the industry evolved through several important stages. Between 1962 and 1975. Mexico focused on producing vehicles for the domestic market and reducing imports. From 1975 to 1985, economic recession reduced production by about 20%, leading many plants to move north. Between 1985 and 1994, the industry began transforming focuses on smaller and more efficient engines. And the 1994 that the North America Free Trade Agreement, or NAFTA, completely changed the game. After NAFTA, Mexico became deeply integrated with the North America automotive supply chain. This opened the door for massive foreign investment and made the country one of the top 5 automotive producers worldwide. Today, the automotive industry represents around 3.7% of Mexico's GDP and provides over 800,000 direct jobs. Companies like General Motors, Volkswagen, Nissan, Chrysler, Ford, and Mercedes-Benz all have production plants in Mexico. Despite the success, maintaining consistent and certificable quality system continues to be a challenge, and that's where SPC and PDCA become essential. Now, let's explore how the research carried out this study. They use both quantitative methods, mainly statistical process control, and qualitative methods such as interviews. The entire research followed to the PDCA structures. Plan. The research first conducted a detailed evaluation of the machining process used in engine remanufacturing. Do. They design and they implement an improvement plan. 3. Check. They use SPC control chart, specifically Escobar and air charts, with the help of Minitab software to analyze process behavior. 4. Act. They conduct interviews with managers to evaluate the decision-making process and identify opportunities for the further improvement.
The real-life case study was conducted at a plant location in the state of Mexico near Mexico City. For confidentiality, the company is called APMEX. This facility belongs to a large German automotive corporation and is responsible for manufacturing truck engines for the North American market. It is ISO 900.00 certified and applies PDCA as the foundation of its quality management system. In this plant, SPC is a key part of operation. They use metrology, control charts, and complete inspection of every machined part to ensure the zero defects. Every 6 months, the staff receives training in measurement and inspection procedures. The research team from University Iberoamericana collaborates with the company between 2019 and 2021. They analyzed SPC data related to the bushing diameter of the engine block, a very critical measurement for proper engine function. Their goal was to identify instability in the process and propose improvement based on the SPC results.
So, what were the results? Before the proposed improvement, the process was unstable. About 33% of the subgroups were out of control. The mean diameter was slightly higher than the specific value, and variability was significant. After implementing the proposal, the process became more stable. Only 25% of the subgroups were out of control. The process capability index improved by 13.8%. The process performance index improved by 17.2%, and the percent of out of specification parts decreased by an incredible 72.7%. Also, process variability was reduced by 88.33%, which meant the manufacturing became much more consistent. This number surely show how the combination of SPC and PDCA leads to measurable and sustainable improvements.
Through interviews with the company's managers, research found something interesting. Although the SPC system was useful for collecting data and detecting problems, the decision-making process was too bureaucratic and slow. When production problems occurred, there were delays in implementing corrective action. The collaboration with the university provides a fresh external perspective that helped identify issues the internal team had noticed, what the authors called workshop blindness. This means that people who work daily with the same process often stop seeing small inefficiencies or potential improvement.
To conclude, this study demonstrates that SPC and PDCA are powerful tools for continuous improvement in the automotive industry. Their application helps reduce costs, enhance product quality, and increases process capability. However, this study also highlights that success depends on more than just tools. It also requires good communications, quick decisions making, and collaborations. Another important takeaway is the value of university industry collaborations. When academic research and industrial experience come together, they can solve real problems and promote innovations. These partnerships also help the students and researchers understand real-world challenge while contributing to national industry development. In summary, the combination of data-driven control through SPC and structured improvement through PDCA represents a powerful approach to achieve excellence in manufacturing. By focusing on prevention rather than corrections, and by continuously learning from data, companies like Abmex can remain competitive in global market. Thank you very much for your attention. I hope this presentation helped you understand how SPC and PDCA can drive quality improvement and continuous innovation in modern industries.